Assalamu alaikum. Today we discuss about this problem. Actually, this problem is related to strength of materials. If if we do this problem clearly, I think it will so helpful for next or others problem like this. Okay, let's start. Find find the maximum value p. We have to find out the maximum value p. That means here is p, here is p, and this is p. Okay, this p we have to find out. Remember, and exceed a stress in a steel of 140 megapascal. In aluminium, for aluminium of these, and bronze for these, and steel for this. This figure will provide in question paper, but this figure we have to draw for our calculation. At first we have to understand this, and the steel A area has given millimeter square, and also the P 4P direction has given left side, and aluminium A and bronze area also P and 2P has given. Also length also they have provided in this figure. From this figure we have to understand how they have drawn this big figure. Okay, 2P. At first we have to consider, we have to know, we have to remember this negative minus actually means compression or compressive force. Okay, compression or compressive force. 2P, this direction 2P is going through in left side. We are considering left side in -2. Left side is -2. If we, for understanding, if we draw the axis, and this axis and x prime and y prime. This side is the positive and this side is negative. Just we're considering, and this side is negative and this upward direction is positive. Okay, we know what we know that, and 2p is the left side, so we are calculating, we are drawing the downward, and this is the 2 because there is no any load. 2p minus 2p and minus 2p, but p is going in right side is positive. That means it will go upward direction. This means if we write this, and p positive minus 2p equal to minus p. This minus p, then minus p, and there is no any load, so it will go a straight line. And again from here is minus p, but this is the minus, that means left side direction is showing us, so it will be the minus 4p. That means minus 5p. Okay, this minus 5p, this one. Again I am telling you, this minus actually indicating us is the force. This force is compression force or compressive force. Okay, now we know our familiar equation. We know the stress we are calculating from steel ST equal to P, that means 5P divided by A, and here we know the stress of steel, because the exceed stress of steel, this is the 140 megapascal, and also in 5P and area equal area. What is area? What area is 500. millimeter square and megapascal is same. If I say this megapascal, that means pascal into 10 to the power 6. And again we know if we convert a millimeter square to 10 to the power 6 meter square, the same. So that's why we didn't work or didn't do any simplification, just we put down this area value. Okay, and after that P will get and 14,000 Newton. Okay, same way is for steel. Same way is for steel. Now for aluminium. P and aluminium for what? The stress is 90 equal to for aluminium only P. Area, what area? Area is the only P. This one P. Area, what will area? Area is the 400. Sorry, 400. And then P equal to, we'll get 36 Newton. 36,000 Newton. Okay. Same way for bronze. For bronze, we know as 100 megapascal as 2P divided by area will be the 200, and then P equal to 10,000 Newton. Okay, our question is that the maximum, to find the maximum value of P, because every materials has P or stress is the difference. Maximum stress is different, but we have to maximum value. That means with P, with load will be low, that value will be considerable for this maximum, because just you remember that, because if you this bar provide in 36,000 Newton, 36,000 Newton for steel, this will sustain, but this aluminum side will not sustain. They will crack or they will fail. Also bronze will fail. If we put an 14,000 Newton, then this aluminum steel will sustain, aluminum will sustain, but bronze will fail. That means a total structure will crack down or will fail down. So as an engineer, we have to consider the 10,000 Newton. If we provide this load in bronze 10,000, this total structure will remain as a safe condition, or that one is the maximum value of P. Thank you. That was very informative uh, informative knowledge, and thank you for fashion. Thank you for listening me.